For many of us, the yo-yo has probably been a crucial part of our childhoods. From little kids to busy adults, the simple toy has managed to make itself a popular pastime for all, so that there's fun for everyone.
The basic yo-yo structure consists of an axle connected by two discs and a string length around the axle.
It is not known who in fact invented the yo-yo, since the existence of the toy dates back all the way to 500 BC. However, a common name you'll come across is Pedro Flores, a Filipino immigrant in the US.
In 1929, he opened a yo-yo manufacturing company and made handmade toys, in which a yo-yo was one of them, making him the first person ever to mass-produce yo-yos.
The yo-yo picked up popularity in the years 1930 to 1960 as the children of the generation took great interest in the simplicity of the toy.
As the toy became more popular, new tricks were invented, and this was a stepping stone for the toy, where after this, every basic household you name had to have a yo-yo.
You may be familiar with some of these tricks, like walk the dog, flying saucer, around the world, and so many more.
Though the initial design of the yo-yo isn't what we see today, the yo-yo has been modified multiple times for efficiency's sake. A major modification to the yo-yo structure was by changing the fixed axle to a transaxle, which helps reduce friction, thus enabling longer, more complex tricks.
Nowadays, there are many different types of yo-yos in the market which differ from the original design, with the key difference being the constructing material of the yo-yo and its string.
Take the loop in the string and place it on your middle finger, between your first and second knuckles. Thrust your arm down, releasing the yo-yo, and spread your fingers. Point them a bit downward while you throw your yo-yo down, rotating your palm to the floor to snap the yo-yo back up.
Considering the mechanics of the yo-yo, you'll discover that it isn't just all fun. In fact, there's much more to it than just the axle and the string. The toy presents many physics concepts, from which some of them include the law of conservation of energy, kinetic energy, force of gravity, force of friction, centripetal force, and tension.
The law of conservation of energy is seen through the constant transfer of kinetic and potential energy.
Experimentally, the yo-yo can prove this law. Note that at the top, the kinetic energy of the system is 0, and at the bottom, the potential energy is 0. Thus, if the gravitational potential energy at the top equates the kinetic energy of the system at the bottom, the law is proved. To show that the length of the string does not affect the law, the same experiment can be performed with different length yo-yos, and it would still be found that the law holds true.
As the yo-yo climbs up and accelerates down its string, it is constantly transforming potential to kinetic energy, and vice versa, helping to keep the mechanical energy of the system constant and supporting the law of conservation of energy.
Kinetic energy in the yo-yo can be seen as two types, linear and angular momentum.
Linear kinetic energy is the momentum of an object in a straight line. This can be seen when the yo-yo moves in a straight line up and down as its string ravels and unravels.
The equation P is equal to mv, or momentum is equal to mass multiplied by velocity, shows that both the speed and velocity of the yo-yo are directly proportional to the momentum of the toy. As the mass or velocity increase or decrease, the momentum will also increase or decrease, respectively.
As mentioned, angular kinetic energy is due to rotation of an object, which can be seen as the yo-yo spins.
Similarly, angular momentum is also directly proportional to its products. The equation L is equal to I multiplied by omega, or angular momentum is equal to moment of inertia multiplied by angular velocity, shows that as the values of the moment of inertia or angular velocity increase or decrease, the resultant angular momentum will also increase or decrease, respectively.
Gravity. One of the most common physics terms that acts on every single body present on Earth is also in action when considering the yo-yo. As the yo-yo falls down, gravity acts on the center of mass, accelerating the toy at 9.8 meters per second squared towards the ground, helping build up its linear momentum.
The force of friction can also be applied here. It can be defined as a force resisting the relative motion of solid surfaces against each other.
It is seen that as the string spins on the plastic axle, friction is created between the two materials. The friction between the string and axle allow change in the angular momentum direction, and thus letting the yo-yo come back up. Without friction, the yo-yo would simply not spin or return upwards.
Moving on, the centripetal force is a force that acts on the object to keep it moving along a circular pathway.
The centripetal force is directed perpendicular to the tangential velocity or the direction of motion.
If the yo-yo spins at a constant speed, then the force applied on the string of the yo-yo acts as a centripetal force, which is perpendicular to the direction of motion of the yo-yo. Considering this case, the Fc would be the F net unless another force is acting upon the yo-yo.
Lastly, tension is also another component in the functioning of the yo-yo. Tension is the pulling force in the string of the yo-yo. As the yo-yo moves down, the tension in the string increases, and conversely, as the yo-yo moves up, the tension in the string decreases.
It's amazing to see how such a simple toy could have so many different physics concepts behind it. So next time you see a yo-yo, don't forget about the tension in the string or the linear momentum that occurs. For now, that concludes our presentation, and thank you for watching.